density, the molar mass, and the ideal gas law. The goal of this video is to learn to interconvert between density, molar mass, and molar density, and we'll talk about two ways of doing this that are very similar. First, we can talk about this in terms of formulas. If we know that density is mass over volume, we know that molar density is moles per volume, and then we can take the ideal gas law and we can see how to interconvert between pressure, the ideal gas constant, and temperature to get molar density. So we can use these three formulas and rearrange as necessary to solve for what we're going to need. The other option, which is really the same thing, just worded a little bit differently, is to look at all the units here. Here, if we think about what our units are of molar mass, it's going to be grams per mole. And if we think about our density of the substance, grams per liter, and our molar density of the substance is moles per liter, we can take and we can use these units just like a formula to solve for what we're looking for. Now, the best way to teach you this is to do an example where you can see it done. Here we have an example where we can go ahead and see how all of these work together. So if we look at all of our values that we have our pressure, we have our temperature, and we'll need to remember to convert that into Kelvin, and we have our density, and we're trying to find our molar mass. And then we have an additional part that we'll need to do at the end to also find the molecular formula. That'll be the same as how we worked through problems in our fundamentals section. If we have this, and we want molar mass, think about our units here. We have grams per liter, and we're looking for grams per mole. We need to have a way to get rid of liters and to get moles. If we think about what we have that has moles per liter in it, that's our molar density. We take our ideal gas law and we solve for molar density, which is N over V. We fill everything in and we remember to switch our temperature to Kelvin, and we get our molar density. We can take and we can see, well, we need grams per mole. We have grams per liter. What can we do so that we can get grams per mole using these two values? If we take our grams per mole or grams per liter and put it over top of our moles per liter, you can see the liters cancel, giving us grams per mole. You could also do all of this by filling into those formulas on the previous slide if you're someone who likes memorizing and using formulas instead. So we'll do this to get our molar mass. Now we need to go on and use the percentages that they give us to find the molecular formula. So now I've just sort of scooted the work off to the side a little bit to make room for the next part, which is going to be the same as the sorts of things that we did in the fundamentals section. Now, since we have the molecular mass, I'm going to take a slightly different method of doing this, and I'm actually going to just, instead of assuming a 100 gram sample, I'm going to assume a 98.9 gram sample, since we know that that's the molecular mass. And you'll see why that works out well here when we go to do it. For carbon, I'm going to start with my 98.9 grams. And I want to see how much of that is carbon. So I know that 12.1% is carbon. So I'll multiply by that. And now, using my molecular mass of carbon, I can convert to moles. Since I started with the molecular mass, when I get done, I get a nice round number. Let's do the same thing for the other two. So we know for oxygen we have 16.2%. And now the last one. And since I'm just going for ratios, I don't have to worry too much about significant figures or anything like that, because it's going to be close to a whole number. And so from here, I know that that is going to be my molecular formula. So in summary, we now know how to interconvert between density, molar mass, and molar density, either by using any of these formulas in a formula form, or by looking at each of the units